Hello and welcome to a new video about Arduino programming. Let's start with the basics. What an Arduino is good for? An Arduino is good for controlling. Okay, what is controlling? Well, I just want to show you briefly what a controller is. So I will draw simply a box and let's say this is my controller. In our case, this is an Arduino, but in general case, this thing is called controller, and we are using the Arduino in our case. What a controller does have? A controller does have a bunch of inputs. Okay, so there are inputs which will give information to the controller. How many inputs? Well, this is not really defined. So usually these inputs are marked with xi. xi1, xi2, xi3, up to xin. Can be many inputs. Simplest case, 1. Those inputs are processed by the controller somehow. So there is a program running in the so-called program, which is processing the inputs. Based on the inputs and maybe some internal states, which I remembered from previous occasions, the controller decides what to do. And what to do is reflected at the outputs. So there are then outputs of the controller. There might be also several outputs of the controller. And with the help of the outputs, the controller is influencing the world. Okay? XO1, XO2, XO3 and so on up to XOM can also be different. An input and an output, they might be digital. Okay, they might be digital. Digital means we only have it there or not there. So false or true, 0 or 1, however we want to call it. So an input and outputs might be digital. In and outputs possible digital. This means just 0 or 1, false or true. In our Arduino world, this means, well, we have for false or 0, we have 0 volt. And for high or 1 or true, we have 5 volt. This is Arduino. So Arduino has a 5 volt logic inside. True is represented by a 5 volt signal, false is represented by a 0 volt signal. This might be, if an input must be true, we must put in 5 volts. If an output is true, it gives us 5 volts. And they also might be analog. So this means something between 0% and 100%. Also something in between. It's a range. It's a range. This is a range. This is only 2. Digital was only 2 explicit states, and this is a range between 0 and 100%. On Arduino, input usually is between 0 volts and 5 volts. This is between 0 and 100%, between 0 and 5 volts. How such inputs are handled? I will explain in a different video. Yeah? But we can read out, and we can read in also values which are not just true or false. We can read anything. It's temperature, for instance. Typical example: temperature. It's just not hot and cold. It's a continuum. Input. And now the output. Well, there are no analog outputs. There are no real analog outputs on the Arduino. They are used PWM, pulse width modulation. What this is will also be explained in a different video when we talk about analog outputs. For now, it's enough that you know there is not a real analog output where we can give something between 0 and 5 volt. No, this is not possible. So, in and outputs, digital or analog, and in the middle this is called a controller. Yeah? In our Arduino, the program is software. And in Arduino, we usually use the programming language C++. Okay, because this comes with the Arduino IDE. We will go in and install this in the next video. But so the logic, which is combining the inputs and calculating what the output shall be, is a piece of software. Such controllers, which have the program in software, and not, there are different methods, maybe in wiring, or if it's not an electrical controller, then maybe also in piping, if it's a pneumatic controller. It doesn't really matter. Right now, for us, this is a piece of software. Such controllers usually are called PLC, programmable logic controller. Is there a second M? Maybe. There will be a second M. Looks better. Programmable logic controller. This is actually what our Arduino is. Our Arduino is a PLC. Well, for a real PLC, some parts are missing. Yeah, the casing is missing, the screw terminals are missing. This is more, it's the core of a PLC. But the functionality is there. So this is actually what an Arduino is good for. Read something in, process it, and decide what to do. And if these decides are following some rules, are meaningful, then whatever is happening looks like it's controlled. This is why the name, controller. So let's have a short look on the hardware of the Arduino. Okay, get the box, and I will show you what the hardware of the Arduino is looking like. Okay, so let's have a look at the hardware. Here's the box. I will open the box. Open it, and well, we have seen what we are going to use is this cable. This cable is for connecting the Arduino to our system. So this USB-B cable, that's it. USB-B cable. This we are going to use, and here in one of these bags there is also the Arduino inside. You can clearly see it. Lego Uno R3. These are the two things we are going to use now. Close the box, put it somewhere else. So, well, this little box, or this little sack actually is a cage, Faraday cage. So this is just for preventing damage, transport, preventing static electricity. If we open it and pull the Arduino out, we see the first time our Arduino. Does not look too spectacular, right? So what we've got here? Let's see. We do have several parts. Well, we have, of course, the USB connector. Here at the side there is the USB connector. We can simply plug in our USB cable there and connect it to our computer. Here we have also a power jack. So at this power jack we can put a power supply, yeah? Then we can run it without connecting to the computer, the program. If we turn it over, here at this side, I'm not sure, let's call it the upside, these are in and outputs, digital in and outputs. They are marked from 0 to 13. Yeah? These are the digital in and outputs, and we can configure if it shall be an input or output. Like I said, there's a 5 volt logic inside there. This is 0 volt for 0 or false and 5 volt for true. Down here, marked with A0 to A5, these are analog inputs. So here we can place usually 0 to 5 volts. Okay. This here is just for USB controller. These parts here. These parts here on the bottom, they are for the power supply. If you're using here the power jack, then these power supply things are starting to work. A power regulator, some stabilizers and so on. This will produce 5 volts. Here we also have some pins. Yeah? 2 of them are marked with, let's see if I can show you, if this autofocus is strong enough. 2 of them are marked with ground. Yeah? There we have 0 volts. It's also labeled on the side. Let's see if I can manage to. Not really. Yeah. So 2 of them are marked with ground. Come on, yeah, a little bit. 2 of them are marked with ground. Now it's good. Now it's good. And then there is a 3.3 volt pin, where 3.3 volt are you can use it to power supply something. Yeah, with 3.3 volt. There's a 5 volt pin. You can use it to power supply something with 5 volt. And this pin, which is marked with V in, voltage in, is actually the same. It's connected to here. Yeah. And then there is also a reset pin. Yeah. The reset pin, this can be used to reset the whole controller. So if you put there ground, 0 volt, a connection between ground and reset, yeah, then this controller is permanently set to reset. Only if this connection is removed, the program on the controller will run. Okay? Actually, the same functionality is here, the reset button. If you touch the reset button, exactly this is what happens. The reset pin is connected to ground, and if you release the reset button, the reset pin is released again. So you can do it either with the reset button or by placing here some cable or something like this. Yeah? This here, what looks like a mechanical part. This is actually the swinging thing. Yeah, this gives us 16 megahertz, I think. 16, all right? Yeah, 16,000. Yeah. 16 megahertz. Yeah, this is the frequency of our CPU clock. Yeah. Well, and all I've shown you up to now are just connectors, maybe power supply and USB connection, and then the swinging part, and all things which really is the Arduino, which is the whole controller. They are all located here in this part. Yeah? This is the Arduino. Everything else is just that you can grab it better. Yeah? This spider thing here with a lot of legs, this is the Arduino. There's everything inside. There is inside, the the CPU, the processor, there's inside the memory, there's inside the flash memory, holding the program and so on. Everything is inside. So this is a so-called system on a chip, or SoC also, or also referred to as microcontroller. So this is the microcontroller. Everything else is that we can touch it. This is our Arduino. And if we want to plug it to our computer, connect it to our computer, we just have to use this cable here. Plug it in here. Plug it in on the other side of the computer. Well, and then we're good to go. However, to be really good to go, we also need to use some software. We're using some programming software. Clear. We said it is software, usually it's programmed in C++, so we need to have some method how to get the software what we want here on this board. Some sort of loader or something like this, and also a possibility to code our stuff, to write the source code. And this stuff is called Arduino IDE. This is what we're going to use in this course, the Arduino Integrated Developer Environment. What this is and how to install it, we'll see in next video. For this time, thank you very much for listening. Goodbye.